Okay. So yes, we're going to work on the code challenge for this week. Was it last week? Anyway. Um, this week we are going to be using Pandas, the data frame to be doing some data. Well, I'm not really doing the analysis, but at least just getting to work with the data frame with our Magi Ndogo project. So we finally started it. And the introduction says that okay, um we are on the project again and we want to start automating farming in Magi Ndogo. And we want to take note of the type of crops we have, the um agricultural landscape, we look at our climate, how everything affects everything. So basically, that's what we are going to be doing. We are going to check things like our soil fertility, climate conditions, and all that. And we'll be getting our data from the SQLite database. So the first thing that we need to do is just to get to know what our data looks like. Um, from here, we see that we have about 1, 2, 3, we have 4 tables from our database. The geographic features, which has the field ID, elevation, latitude, longitude, location, and slope. They also include like the type. So we have big int, float, text. These are like the 2 types or the 3 types we have. Then our weather features table, which also includes our field ID again, rainfall, minimum temperature, maximum temperature, average temperature. All of them are in float except the field ID. Um, Then we have our soil and crop features, the field ID once again, the soil fertility, soil type, and pH. So we have float, we have text, we have another float type. And then lastly, the farm management features. So the field ID, pollution level, plot size, chosen crop, annual yield, and standard yield. So basically, this is the table. These are our tables. We have 4 tables with different, columns in them. And then to note, these are the crops that we have, or the crop types. So we have coffee, wheat, rice, maize, tea, potato, banana, and cassava. So this is, excuse me. So these are our crops. We have about 8 of them. Now, the first thing we look at is importing our SQL data into our data frame. We've looked at creating data frames from, NP arrays. We've looked at creating data, reading it from like a CSV file. Now we are going to be importing from a database. Yeah, from a database. So we've already been given the code, so you don't really need to think of anything. First of all, import your pandas, and then import some functions from SQL Alchemy, and then you're going to create your engine for the database. So this is the way you'll be able to connect to the database at every time. Yeah. So if you run this, excuse me, so it has run, and then we have to check, okay, is it correct? So basically what this is saying is run this SQL statement here. So if we know from our SQL, this is like an SQL statement. Select from SQLite master where type is table. So it's an SQL statement, and it's basically just saying run this statement. So when we run it, it gives us all the tables that are in the database, which is the same thing as what is expected. Now, the next thing we're supposed to do is we've gotten okay, we can connect to our database final right now. We need to import it into the data frame. We need to import it into our data frame. So you can either do it in 2 ways. First of all, you can either say, okay, will import each table into their own data frame, then merge it into one. Or we can just use one SQL query to read to read everything and then put it inside the data frame. So if we remember from our SQL class, if we remember from our SQL class or course, um, there was a way for us to actually join tables using the join field, the join statement or the join statement. There's a way for that's the way that we can join our tables. And if we notice, all our tables have the field ID that is common to them. So we can use that to join our tables into one singular table, and then we'll import it to our data frame. So we don't have to do importing one by one, then now merge. So we have to write that query, yeah? I'll just I will just write it, hopefully. Um it will be like a select all from um our first table is geographic features. Okay. Select all from geographic features. Then we're going to join it with we're going to join the weather features. So we're going to merge these tables on geographic features dot field ID is equal to weather features dot field ID. So this is just our normal join statement. So we'll do the same thing for um soil and crop features and then farm management features. So I can actually just copy this, but then change the table name. So soil and so join soil and crop features on geographic is equal to soil and crop features, and then we'll do for farm management features. So join geographic features is equal to farm management. So this is just basically your basic SQL statement. So we can run this. So we've saved this statement in this our variable called SQL query. Now our engine is okay. Our engine is ready to connect to our database. So this is just a statement to use with engine connect as connection. So this is our data frame that we are creating. The MD agric DF is our data frame. And then you run this function, read SQL query. So your pandas.read pd.read SQL query, and then convert this to a text. What we just did here, our SQL query, and then pass the connection, which is the engine we just did. So if I run this, it has run. Some of you will have error here. Will get an error saying something like, oh, you cannot use the read SQL query or something like that. Most times that's because your SQL alchemy is a lower version and you need to upgrade it so that the pandas is can connect to your SQL, because if the versions are not compatible, it's going to give you an issue. So you have to upgrade your SQL alchemy. You just do it by doing pip install upgrade and then SQL. So once you run this, it will upgrade your SQL alchemy. Then when you run this, it will not give you any error again. Now let's check if our data frame is correct. So if we click here, yes. So we have 5,654 rows and 21 columns. So this is our data. our data frame. You can see we have all our columns: field ID, elevation, latitude, longitude, down to the standard yield. This is okay. Now we have to drop all the columns new field ID because we just used it to merge our tables together, but we don't really need it for whatever analysis we want to do right now. So we can drop it. And once you drop it, if you try to see it again, we have 17 columns now. The field ID, there's no field ID column anymore. Now, after you've gotten your data, you can't just use it to start doing your analysis or whatever. You need to clean whatever you can clean, just like we did in our SQL and in our spreadsheet class. So there are about 3 errors that were noticed. So first of all, there are some swapped column names. We can also see that some of the crop types contain spelling errors, and then the elevation column contains some negative values. So we need to actually clean up everything and make sure that there is no error anymore. And then these are the checks we'll use to be sure that our data is clean. So the first thing you have to check is you have to get an overall understanding of what your data frame looks like. So we can use the function, the pandas function called info. When you run this, you're going to see basic information about your data frame. So we can see our columns, we can see the columns that are not null. So there's no empty column, or there's no empty field. That's what it's telling us. There's no empty field. And then we can see our data type. So we are seeing floats, objects. Texts are object type. They are the object type. Then floats are for the float, then your int and all that. So the first thing we are checking is there are some swapped column names. If we notice from our first I think I wrote that, I did that in this. Okay, yeah, I have this here. If you notice, first of all, in your farm management features, we had pollution level, plot size, chosen crop, annual yield, and standard yield. Now, if you follow this, you see that there's nothing called chosen crop. So it is called crop type now. So you need to make sure that, okay, you don't use chosen crop because that's what we are giving your data dictionary. You're going to be using crop type for whatever thing you need to do with the crop type. And then if you notice, the chosen crop, which is now our crop type, is text. But when we look at it here, it is a float. It is float. And then our annual yield is supposed to be a float type. It's supposed to be float type. But when we look at it, it is an object, which means that there's something wrong somewhere. So what we need to do now is to, just take a look at what our data looks like. So would get our DF and then just look at the crop type. Let's see what our crop type looks like. Crop type, okay. So we're seeing our crop type is 0.7, 1. This does not make sense to, it doesn't correlate with our, with our data. And then if you look at our annual yield, excuse me, our annual yield is cassava, tea, potato, maize. So we can see that the two of them were swapped, maybe due to data entry errors or something. The columns were swapped. So we'll have to make sure that we'll swap them so that our annual yield is actually containing the float values, and then our crop type is actually containing our crop type. So you can actually do it in the use the normal Python function that we use to swap. So we already have our annual yield. So let me just copy this. Sorry. Let me just yeah dot well. Yes, this is actually the same. This thing I'm writing here is the same thing as this. This is the same thing as this. So maybe I should just use this. Same this one we thought. It's the same thing. So now we can swap it. We can swap it. I think they taught us this like 2 weeks ago or so. It's easy for you to swap. You just have to like MD IBDF crop type and then annual yield. So instead of crop type here, you put your annual yield. So it's swapping it. It's assigning the values of the annual yield to crop type, and it's assigning the values of crop type to annual yield. So this is the way to, and then when we swap this, let's run it. So we run it, and then let's check if the thing actually changed. So I want to see the two of them together. So we'll have our crop type and then our annual yield. So we can see them side by side. So we can see now that our crop type is now showing cassava, wheat, tea, and our annual yield is showing the correct float values. So this is just the way you can swap it. It's the normal Python way of swapping variables. So we can do it this way. Now, we have we've done the first data cleanup. It was easy, hopefully, or simple rather. Now, the next thing we are going to do is to check. You said that some of our crop types contain spelling errors. We have spelling errors. So the way you have to check it is so let's just see MD agric. We have our crop types. Sorry, crop type. We have our crop type, and then we have a function to show us the unique value. So you can use the unique function. So you just dot unique. So this is the unique function. And when we see it, we are seeing that we have how many unique crop types. You can do this by adding an n in front. This tells you, show me the number of unique. Don't just list them out, just show me the number. So we have 14 unique crop types, but according to our data dictionary, we had about 1, 2, 3, 4, 5, 6, 7, 8. We have 8 unique crop types. So there's something wrong with our data. When we look at it, first of all, you can see we have cassava, tea, wheat, potato, banana, coffee, rice, maize. And we also have wheat. Is the correct spelling, but there's a space. We have tea. Is the correct spelling, but there's a space. And then cassava, for some reason, is spelled as cassava. Wheat is spelled with N. There's cassava with a space, and then tea with another A attached to it. So we can see that there are basically two problems. There's a spelling error, and then there's space. So space is when you have something like wheat with an extra space is a different thing from wheat. Is a different, they are not the same thing because of that extra space. So we need to look for a way to trim our values or remove the extra space, and then make sure that our this thing, what they call it, our values are correct. So the first thing we'll do is let us remove our space. Let's remove the space from the data. So very, you can just, let me just copy this so I don't have to be typing every time. So, excuse me. So now we can see, okay, the MD, and crop type. So what we would assign it, because we are replacing it. So we are replacing it with, there's our last 2 weeks, they taught us about string functions. So what you do is, this is a string, so you use str. You use str when you want to call a string function on the data frame, so that it's you can apply whatever function that you want it to do on the data frame. If you just do it without putting the str, it will not work, because you have to show that, okay, this is a string function, and then perform this operation, or perform whatever you want to perform on it. So str dot, the Python, what's the Python function for removing spaces? Can anybody write it on the chat? What is the Python function for removing spaces from a string? Does anyone know? Let's see. Ah, I don't know. Okay. Maybe, I'm not seeing. Sorry. So, okay, maybe we don't know. So the function for removing or trimming, yes, strip. Thank you, Wilson. Strip. Strip is the function that you use to remove spaces. So you can use an L strip. L strip means remove white spaces from the left. So if you have something like, maybe just excuse me, if you have something like width, remove the space from the left. If you have something like this, you can use arrow strip to remove from the right. But I'll just use strip so that in case we have both left and right, it will just do that. So now if I run this, it has run. If I now run this our unique function again, if I run this cell again, we can see that it has reduced. Whatever we are doing has reduced. So now, the next thing we need to do now is to check our is to change these things to the correct one. So we need to change cassava to cassava, wheat N to wheat, T to T. So excuse me. A way we can do that is to have our function. We can create a function that does that, and then we'll apply it to this crop type column. Now we can create a function by using the def, and then let's say we call it change spelling, and then we're going to be passing the crop. So whatever crop it is, we are going to be passing it, and then we'll write our we'll write our function. Now there are different ways you can do this. You can say, okay, if the crop is equal to, now this one is like, let me say you're hard coding it, in the sense of, if it is cassava, then maybe return cassava, something like this. But what if now you have like cassava with L, you have cassava with like something like maybe cassava, like things that are just, the cassava misspelling is so much. Would you write it one by one? So maybe so what we can actually do now, instead of hard coding it, maybe I will do it for the next one. We'll do else if, let's say we put our elif, if crop is in with if crop let me just continue. If crop is wheat and mind you, okay, return wheat, and then the last one, if crop is tea, return tea. Now, if the crop is nothing, if it's not part of this misspelling, what we can do is just to return the crop. So what this does, let me explain a bit. If we have something like cassava, if it's cassava, it's going to return the correct spelling of cassava. If it's wheat, it returns the correct spelling of wheat. If it is this, it will return the correct spelling of tea. But we can also sorry, we can but if it is not any of it, let's say it's the correct spelling of cassava, we have to return the cassava back. Now, if we have like multiple misspellings, it will be hard for us to actually write everything. Okay, if we have maybe T with 2 A's, 3 A's, 5 A's, 10 A's, do we have to write all the different variations of T? No. One thing we can actually do is um one thing we can actually do is we can use the in function. So we can say if T is in crop. So what this means is if there's a substring called T in crop, you can then return T. So even if I have T I don't have to like write every single variation of T. Obviously, this can present some problems, but for the basic distance, we can use this. So we can run this from we can run this cell, and then we can apply. Let's apply this to our crop type. So we use the apply function, and then we use our function. We call our function. So this applies it to every row or every row in this column. So if we run this, it ran. If we check this now, we see that our values are now unique. Let's say I put n, I want to know the number. So we have 8, which is correct. So we have 8 unique values. I hope this is understandable, at least up to this point. So the next thing we are going to do is our elevation column. So we've swapped our column names back to the correct ones. We've removed the spelling errors. The next thing we need to do now is to change our elevation column to positive, because if something is elevated, it has to be positive. It can't be down, then it's depressed. So let's check. Let's just have a bit of understanding of what our elevation column looks like. So if I have let me look at our elevation column, elevation, that's the name, and then look at the minimum value. Now, if you look at the minimum value of our elevation here, of our elevation column, you see that it is a minus 878, which is not possible. If something is elevated, it has to be from 0 plus 0 point something upward. It has to be above 0. It has to be positive. So now we need to look for a way to actually change, or we need to look for a way to actually, make our elevation values positive. Now, there are several ways. Again, in programming, there are several ways to do things. So we can say, okay, we want to write our own function, change this to positive. We can even write a lambda function, we can write a normal function and check. We are not going to use this, but I just want to show. We can say, okay, we want to have our own function saying change to positive, we pass the number, and then we'll do, if the number is less than 0, return. Now, if the number is less than 0, you just need to multiply it by -1. Minus times minus will give you plus. So that's just basically it. So if the number is less than 0, return the number times -1. Sorry. And then else you just return the number. So we could say, okay, we can do the same thing that we have in this apply. Sorry, I didn't complete it. We can do the same thing here, and then you know it will work. It will work. It will work. But there's another way we can do it. There's already a function, a Python function, a pandas function. You can use it for most of the maths. There's a math function already or something like that. So what we can do is we'll take our elevation, because we want to replace the negative with the positive. So would use the .apps function. I will just show an example so that we can get it. So for example, say you have an array that you're um you're turning to a data frame. So let me just, for this purpose, let me just import NumPy to NP. I just want to show something. Let's say you have an array. You create a NumPy array, and it has, let's say -1, 0, 2. The first row has these values. The second row has -9, 7, like this, right? And then you make it a data frame. For example, d.data frame array. So if I oh, sorry, I didn't close this. If I run this, so this is how a data frame looks like: -103, -9, 7, -34. Now, if we run this absolute function, which is saying, run this abs function, we say if change every number to the positive version of itself, basically, you see that now it is 103, 97, 34. So there's already a function for that, which we can use for our elevation. We don't have to write any other function. So we can replace our elevation column with the positive version of itself. So now if I run this, so what I do is just to call the absolute function on it. If I run this and then check the mean, okay, I can use this, and I check the minimum value, we see now that our minimum value is now 35. So we don't have any function that is, any value that is less than 0. Our values are now positive. We just did that by calling this absolute function on the column. So let me see. So our data cleanup should be done. So let us use the check to know if we are done with it. So first of all, check the length of our unique crop type. The minimum value is the same with this, and then our annual yield should be of a floating type. So up to this point is the data cleanup that we've been implementing. Now we have about 5 challenges that we'll do. So I'll just explain what we need to do, what you need to do for each of them. Now, the first thing is uncovering the crop preferences. You need to check, okay, excuse me, please. So they said, now we have our data ready. Let's understand where the different crops are grown. So the first thing we need to do is they said we need to determine the optimal conditions for each growth by analyzing, the data related to elevation, rainfall, and soil type. Now, it said create a function that includes the t fields and return if a tuple with the mean rainfall and mean elevation. So your function takes your data frame and then it also takes the crop type that you want to filter it, and then to return the average rainfall and average elevation. That's just what you're doing. So what you need to do is just first of all filter your data frame by the crop type. Filter your data frame by the crop type, and then once you filter it, return the mean of your rainfall and the mean of your elevation. That's just it. So get a data frame that is just for that crop type, and then return the mean of the rainfall and return the mean of the elevation. Remember, it's supposed to be a tuple that you return. So basically your return should look something like this. So return the mean of the rainfall and the mean of the elevation. So that's how your return should look, so that it will pass the auto grader. So that's what this challenge does. Now, the second thing that we're looking at is finding fertile grounds for ground. So we need to know the places with with high soil fertility, and then we are grouping our data by the soil type. So basically say create a function that groups the data by soil type and returns your soil fertility. So it's simply you group your data by the soil type, then return only the soil fertility column for each of that soil type. So it's going to look something like this. So you have loamy 0.58, PT, this thing. So you just group by the soil type and then return only the soil fertility column. That's what you do. That's what you do. So now the next challenge is the climate and geography analysis. The climate and geography analysis. Now, it's similar to what we do in this second challenge, but rather than just what you're doing is just group by whatever it is, what this column that is passed here. So if they give you a crop type, you group by crop type. If they give you pH level, you group by pH level. Whatever they give you, you group it by that. So you group your data frame by this column, and then you return. Now you're not returning only one column, you're returning also the elevation, the minimum temperature, the maximum temperature, and the rainfall. So your data should look something like this. So you group by the column that is being passed here, and then return elevation, minimum temperature, max temperature, and rainfall for each of that group or each of those groups. Yes. The next challenge is it's taking things up a notch. Sorry. So what you need to do, so now we're going to look at which crop is the top performer in Maji Dogo. Which crop is the top performer and what conditions does it perform well in? Now, the first thing they said is we need to filter all the fields with an above average standard yield. So basically, you have to first of all find the average standard yield. Then once you find the average standard yield, you're now going to sorry, once you find the average standard yield, you're not going to filter all the fields with above average. So they have to be greater than that average yield that you found. And then you group by the crop type. You group by crop type using count. This is the aggregation you're using. So you're using count aggregation. Thing. Now, they give us a hint basically. So this is almost everything you have to do, honestly, this line. But you have to first of all filter your fields with an above average standard yield, and then this group by is similar to what you're going to do. It's just that rather than grouping by soil type, you're grouping it by crop type, and you're using the count aggregation. You're using the count aggregation rather. You're using the count aggregation, and then um everything else is actually the same. So but you're grouping it by the crop type, and then you're using the count aggregation, and then you're going to return the string value of the crop type. This is the way you do it. This is the way you do it. So when you print, if you try this now, let's run this so that you understand. Now, this returns the name at the first index. So this is index 0. So it returns the name at the first index. So what you're returning is actually this first index. This is what you're returning, the first index. So you're going to do whatever I need to do here, and then return the name, the index 0. That's what you need to do. And then whatever you get here, your type is expected to be a string value. And that's it. The next challenge is so now that we know that whatever you got here is our most successful crop, we can look at what makes it successful. Now you create a function that takes the data frame and the type of crop and then does a filtering. So it's just filtering that we are doing. Basically, you're going to filter. We have about 4 different filters that you're using. So you can do it stage by stage till you get what you want. So the first thing is that you filter by crop type, which we have been doing for the other challenges. You filter by crop type. You then select only the rows that are above average standard yield. So whatever you get, the data frame that you got, you have to select the rows that have above average standard yield of that crop type. And then once you do that, you select also only the rows that have the average temperature greater than 12 or equal to 12, but less than or equal to 15. So they should be between 12 and 15, 15 being inclusive. So the temperature should be between 12 and 15. And then you should also have a pollution lower than 0.001. You can break it step by step. So you do the first filter, assign it to a data frame, and then let's say for example, you have your crop type data frame that you will get once you do the filter. Then once you do the average filter by average above average standard yield, you can maybe call that your above average data frame, and then do that field. It's just so that you can take it step by step. You can do it in 1 line, you can do it in 2 lines, you can take as many lines as you do. Just do it in the way that you understand every single thing you need to do. So by the end of this, when you run this, you should get 14 and 17 as the shape. So that's 14 rows and 17 columns. Now this is just what here we don't have to do anything. It's just it's just show you, giving a hint of some the easier way to actually do filtering. So instead of you writing this, what this is doing is getting filtering the fields that have standard yield greater than 0.5 and the soil type is also equal to loamy. Like if you have something like this line now, this particular challenge has about 4 filters. By the time you write it, it's going to be very bulky if you're using this method. So they said what you can use is just use the dot query function, and then you can just write it like SQL syntax. So you just say, okay, what are you creating? So we want to check the standard yield is greater than 0.5 and soil type is equal to loamy. So it makes it shorter, it makes it cleaner, it makes it understandable. So even if you have another field, you can just say, and whatever you need to check, and whatever you need to check. So it's easier than writing this bulky, this bulky thing. So if we do this, we can actually run it and check. Yes, sorry. Can run it and check. So It's the same, it's giving us the same thing, 808 rows, 17 columns. It's the same thing. And then you can even use variables. It makes it easier, so you can have your variables and then just easier for you to actually write it in the query. And then we can also plot our data with pandas. You have to, if you run this and it doesn't work, you have to install matplotlib. If you don't have matplotlib, it's going to give you a bit of an error, because that's the default library too. So you just install, I don't know if matplotlib, if you don't have it. Instead, when you run this, it's going to plot a bar chart for standard yield and for crop type and standard. So it's grouping it by crop type and then your standard yield. So your crop type is your X and your standard yield is your Y. You can also plot a histogram. So the thing that's actually changing a lot is the kind. So this is a bar chart, this is a histogram, how many bins. Let's say you want your bucket size to be 50. So it will change it. And then if you want a scatter plot, so you change your kind to scatter, what do you want as your x-axis? And this. So this is actually it. It's actually, so what you need to focus for this challenge is you need to check your group by, you need to check your filtering, and then it's going to be quite easy for you. So just take your time and do it as much as you can. Yes. So I think I'm done. If there's any question, then I can take it. Yeah. Does anyone have any question? See why? Is there any question? Let me know. Oh, let me check the chat. I hope it's okay. Okay. Yeah. Thank you. Thank you. Yeah, I think everybody understood it. I'm saying, okay, I think it's people understood it. Oh, thank you, everyone. So you just have to take it step by step. Python, it's simple but not easy. You just need to know what you need to do and then follow through with it. So I hope this will help us in our code challenge, and hopefully we get 190 as the case may be. um Admin or Cynthia, over to you. I think, is it?
Wow.
Yeah.
Thank you. Thank you very much. Thank you very much, Naomi, for that incredible session. Guys, let us give her some we can give a thumbs up, we can give her the heart emojis, we can also applaud. It is acceptable. That was incredible. It was really amazing. Thank you. So thank you all. Thank you all for being around and also sticking on until the end. The session was really enjoyable. And besides that, Naomi has not taken a lot of time. So thank you very much, Cynthia. So mine is to encourage all of us to always embrace the spirit of working as a community, helping where we can, and yeah, giving the very best. So I'll pass on to Cynthia. I believe Cynthia is around. I'll pass on to her so that she can wind the session for us. Cynthia, are you around? Okay, I believe Cynthia is not around. So guys, thank you very much for joining in. So mine is to wish you a great evening. And before we wind the session, Naomi, you are the host. So I would request that you stop the recording from your side, and then you're going to maybe download the